Hello engineers, you are welcome to Chris Control Automation. Today we are going to look at Autotransformer starter. Alright, Autotransformer starter. We are going to look at the steps in designing or drawing Autotransformer starter, both the control diagram and then also the power diagram. Alright, it is very practical, very understandable. Okay, yeah, if this is the first time you're watching this channel, I'll urge you that you hit on the subscribe button, alright? Then you hit on the bell icon, okay? In order not to miss my videos, okay? So let's get started. So engineers, when we talk of autotransformer, okay? An autotransformer is a single winding transformer that has both the primary and then the secondary windings on the same winding. All right, it is a single winding transformer that has both the primary winding and the secondary winding on the same winding. All right, so now before we begin with the power diagram and then the control diagram, let's explain the autotransformer itself, okay? And then later you use that scenario to design the power diagram. All right, so now this is the autotransformer winding. All right, so it looks like this, okay? Just a single winding. All right, and then this is the primary winding, okay? That is the primary things, that is the NP, okay? Yeah, NP. And then we obtain the secondary windings by tappings on the primary windings, okay? So on autotransformer starters, all right, we have three main tappings. That is 50%, 65%, and then 80%, all right? So now, the first tapping, all right, will be here, okay? The second tapping will be here, and then the last tapping will also be here. All right, you see that? So these are the tappings on the primary windings that makes up the secondary winding. All right, so these are the secondary windings or the tappings, okay? So each of them with respect to this side, the common side. All right, yeah, okay. All right, so between 50%, this side is 50%, okay? 65%, and then 80%. All right, yeah. So between 50%, okay, this side, okay. So let's see that, okay, when we give 415 volts, okay, to the primary winding, all right, let's see the voltages that we will get from the secondary tappings. All right, okay, so with 50%, it is going to be 415 times 0.5, okay? So it is going to be 415 times 0.5 is 207.5, and then between 415, okay, times 65%, so 415 times 0.65 will give us 269.75 volts, okay? And then 415 by 80%, 0.8, to give us 0.8, 332 volts. You see that? So now these are the secondary tappings, okay? So this is vein 1, let's say vein 1, okay, will give us 207, and then let's do it this way. Vein 1 is equal to 207.5, okay, yeah, and then vein 2
V2, okay? This is V2. So V2 is equal to 269.75 volts. And then V3, all right, to be this one. V3 to be this one. Okay, yeah, between 80% and then the common. So this one will give us 332. 3 V3 is equal to 332 volts. All right. So now these are the secondary tappings. Okay. So when you supply 415 volts to the primary winding, okay, we are going to get the NS. All right. This side is the NS. Okay. The secondary windings. All right. To be this percentages. All right. And then their corresponding voltage are these ones. So 50% of 415 will give us this based on the tapping because it is small, okay? Just few winding, all right? Okay, and then 65%, okay, will give us 269. So from here and here will give us this voltage. 80% will give us 332 volts, okay? So now on auto transformers, always they use 65%, okay, 65% tapping on the primary winding, okay, 65%, okay. So that is what mostly they use. So 65% in common to, okay, common to this winding. The reason being that, okay, we applied 415 to the primary windings, okay, but we are getting this side to be common. Why? Because auto transformer always the secondary side, okay, there is a start point. And all start points are neutral, zero potential, okay, neutral, okay. So we are going to use this same scenario to design the auto transformer power diagram, all right? Yeah, so now on auto transformers, we have 3 contactors, okay? We have 3 contactors, that is, we have the star contactor, okay? And then start contactor, okay, and then run contactor, okay. These are the 3 main contactors that we have in the auto transformer power diagram, okay. So we are going to design the auto transformer power side, all right. So we have our 3-phase here, our 3-phase. So this is our 3-phase line, okay? Line 1, line 2, line 3, okay? So now, this is it. So let's bring the cable here. All right? Yeah. So this one comes from this side. And then this. All right, okay. So now the start, okay, sorry, the run contactor, okay, will be here. All right. Okay, you see that? This is our overload. Then this is our 3-phase motor. Okay? All right. Okay, this is our 3-phase motor. This is our overload. So this is our run contactor, okay? Let's make it R, run contactor, all right? Okay, and now it is left with our start contactor, right? So you tap from the same lines, okay? You can either equally tap from here or you can join them from here, any way we like it. Okay, yeah. So let's make it from this side. So line 1. This line 1. Okay. Right. Line 2. And then line 3. All right. Okay. All right. So this is our start contactor. So let's make it S1. Okay. S1. All right. This will be our S1. All right. Okay. So now this one will pass through the autotransformer winding. So this is the autotransformer winding. All right. This is the winding. Okay. There is it. Okay. All right. And then we have the tappings on it. Okay. These tappings. All right. Tap 1, tap 2, tap 3. All right. So this is the middle one. This one. And then this. We have here this. And then that. We have here this. And then that. So these are the primary windings. Okay. And these ones are the secondary tappings. Okay, the whole winding, okay, is the primary winding, but the tappings on it are the secondary side. Okay, so these are the secondary side. All right, yeah. And then the main voltage, okay, will be applied to the primary windings. All right, as I told you, okay, here the main voltage, the 415, is applied to the primary windings. Okay, yeah, this is it. All right, okay. So we are going to join this one like this. You see that? So we have applied, okay, the main voltages, okay, when this contactor picks up, we have applied the main voltages onto the primary windings, all right? And then the secondary windings will be these ones, all right? So now, it is left with our star contactor, all right? So now, we are going to design another contactor down here, okay? So we are going to start, I'm going to join this side together, all right? The 3 windings, I'm going to join them together, okay? All right. Okay, so let me explain something here. Okay, now, when we start, okay, the autotransformer starter, the moment you press on the start push button, okay, this is S2. The moment you press on the start push button, all right, this star contactor, okay, the star contactor, it will close, all right, to close, and then it will join. It means that it will join these windings together, making a star point, okay, making a star point, all right, or neutral point, okay. Yes, it will join this windings together, making a star point or neutral point. All right. So now, after that, this contactors, okay, the start contactor start. okay, the start contactor will also close. So it means that when it closes, the 415 volt, okay, is applied to the 3 windings, and then we start this side together. So it means that this side becomes a 0 potential, okay, 0 volt, all right, 0 volt. So in that case, we applied three phase voltage, okay, 415. This one, look at this diagram, 415 to the primary windings, right? But because this contacted, this star contactor, all right, it will star or join the other ends, okay, of this windings together, making a 0 point. It means that here too you have a 0 point here. That is why we have a 0 potential here. Though we applied, okay, 3-phase voltage to the primary windings, but on the secondary side you have 0, okay, common point here, okay, common point. It is common to all of this, all right. So now let's see here. So these contactors, okay, these contacts are here. They will start this one. Okay, now we are going to tap from the primary windings to the motor. We are going to tap from here to the motor. Okay, so that's how it's going to be. I told you that on auto transformers we normally use 65%. Okay, so the middle one, I told you use 65%. All right, so this is 65%. All right. Okay. So it is line 1, all right, and it's supposed to go to line 1 here. You see that? And then come to this side, all right? It is line 2. It's supposed to go to line 2. You see that? Now I'm left with this winding, all right? All right, so now this is the auto transformer starter. That is the power side, all right? Let me come back. So when you start, okay, when you press on the start push button, all right, this, okay, this star contactor, star, all right, let me write it here. So run, start, and then star. Okay, these are overload. Now when you press on the start push button, okay, the star contactor will energize first, but it is very fast. It will energize, okay, then it will start this side together, okay, to join them together, and at the same time this side will also close. So when it closes, okay, it means that we are getting a reduced voltage here, all right, based on the tappings. Okay, so we have the 3-phase voltage applied here. So this will be a common point, a 0 point. When you put meter here, okay, and here, you get different voltages per the percentages, all right, as I told you. Okay, definitely you should get these voltages. Okay, so now let's see here. Because we tapped from the 65%, okay, 65%, the middle one is the 65%, all right, I told you that. Okay, you are going to get 269.75 volts. Okay, so it means that as you have applied 415 volts, okay, 415 volts to the auto transformer, okay, based on the tappings, you are going to get 269, okay, 0.75 volts applied to the motor. Okay, applied to the motor. So in this case, the motor is not going to receive the full 415 volt, but rather it is going to receive 269.75 volts. So in that case, the motor is going to run on low speed. It is going to run at a reduced voltage. At a reduced voltage, all right, based on the tappings. Okay, and now it has a timer. All right, the control circuit is here. Okay, it has a timer. So after the preset time, okay, this star contactor, okay, it will de-energize, it will go off. Okay, to go off some few seconds. Okay, and then this one will also go off to open. But why is it that this one should open first? Because this one will open so that part of the auto transformer winding, all right, part of this winding, okay, because this one is open, this side is closed, okay, so part of this winding, it is serving as a reactor or choke, so that the motor would still attain or maintain its speed. All right, they shouldn't open at the same time, so we call it closed transition. Closed transition. All right. Okay. Now let me bring the control circuit here. This is the control circuit. All right, for the auto transformer starter. All right. Let's explain here. Okay. We have our fuse here, our overload relay, stop button, start button, control relay. Okay. Yeah, and then timer relay, S1. Okay. I said the S1. Okay. All right, so okay, let's change here. All right, let's make here S2. Okay, let's make here S2. Then this rather will be our S1. Okay, based on the control circuit. All right. Okay, based on the control circuit. All right. So this will be our X1. Okay, this is the S1. So this will be our S1, and then this will be our S2. Okay, so please kindly pay attention. All right. Okay, so now we have our S1, that is the star contactor. All right, star contactor, and this is the start. So star contactor and then start. Okay, this is the run. All right, this is on delay timer. On delay timer. All right, yeah, okay. So now I said this is our star contactor, start contactor, and then run contactor. Okay, so when the start button is pressed, okay, the control relay would energize. Okay, this contact will close to serve as a holding on, okay, contact, holding in or holding on contact, so that when our start button is released, all right, so this side will close to maintain this one. Okay, this side will also close because they are all open contact on this contactor or relay. All right, I use relay. So when this relay energizes, this side will close, this side will close. Okay, now allowing current to flow through the circuit. Okay, so current will flow through the timer, and then the timer will energize. At the same time, this is a close contact on the timer. This is a close contact on this run contactor. So because they are all closed, okay, as soon as it closes, timer will energize. This current will flow through the closed contact, okay, through the S1. So the S1 is the star contactor. So the star contactor will energize. All right. So let's see here to energize. So the moment it energizes, this side will close. Okay. And when this side energizes, it has its open contact here. Okay. So we have a closed contact. This side will become closed because when this one energizes, the star energizes, the star contactor energizes, this side will close. And then to energize the S2. So it means that before the S2 will energize, the S1 should energize first. The S1 should energize first. Okay. So now, the moment you press it, this one will energize. Okay. And then this side will also energize. All right. And then applying the 3-phase voltage to the auto transformer. And now we have started this side. Okay. And then we have tapped 65% of the windings to the motor. So it means that the motor is now going to run with 269.75 volts instead of the 415 volts. All right. Yes, I hope you understand. instead of the 415 volt. Okay, so the moment this side close and this side close, the 415 is applied to the auto transformer winding. All right, but because we have started this side, okay, we have gotten a zero potential. Okay, so now we have tapped 65 to the motor. Okay, to the motor. All right, so now the motor is going to run on 269.75 volt. Okay, 65. All right, 65%. Okay, it's going to get this voltage. All right, okay, so now let's see the controls. Okay, so now the timer is counting. All right, so after the preset time, let's say you gave it 5 seconds. Okay, after the preset time, all right, all the contact on the timer, they will change their state. So the timer has its close contact here, at the same time its open contact here. Okay, so let's see what happens. So when the preset time reaches, all right, this side will open. Okay, the moment it opens, it will de-energize the S1, that is the star contactor. So this side will open, and then the auto transformer will act, okay, will act as a reactor or choke, because when this side opens, this side, they don't open at the same time. This one will open first before this. All right, so that the motor will not come to a standstill. All right, so in that case, when this side opens and this side is still closed, okay, it means that part of the windings, okay, is acting as a reactor or a choke. It is now in series. It is now in series with the motor, with the line. Let's see, this side is open, but this side is closed. So let's see. See here. Okay, you see it, and then it will go like this. You see this one too. Right, let's see this one too. You see, they are all in series. So it means that when this side opens whilst this side is closed, part of the winding, not the whole winding, part, okay, from here to here, it is going to be in series, okay, with the motor windings acting as a choke or reactor, okay, so that the motor will still maintain its speed. All right, so now when this side de-energizes, okay, when this side de-energizes, all right, when the timer contact change its state, okay, when it change its state, okay, when this side opens, this side closes, this side is going to this relay, this contactor, that is the run contactor, okay, it is going to energize. All right, it is going to energize. So now this run, when the timer contact opens to de-energize the S1, okay, this side will close to energize the run contactor. So let's see what happens here. When the run contactor energizes, okay, let's see here, this side will close, okay, but at that same time this side is still closed, it is not open. So this side is closed, this side is closed. So when this side closes, okay, it is going to short. It's like it is going to short this one together, because this side is closed, this side is also closed, but it is momentary. It is very fast. Okay, it is very fast. All right, so let's see here. When the R1, when the run contactor energizes, okay, it is now going to open this contact, because this contact is on the run contactor. So when this side, okay, energizes, it's going to open this side, and then the S2 will go off. So the S2 is the start contactor. So when this start contactor goes off, or it de-energizes, okay, it is going to open this side. It is going to open this side. All right, you see that? So it means that always when the timer preset time reaches, okay, the start contactor will go off, but it shouldn't go off with this one. The two of them, they shouldn't go off at the same time. This one will go off first. We call it closed transition. All right, so when this one go off first, okay, and then the timer contact, this one would energize the run contactor. Okay, so this side will also close. So we have a close here. So when this one energizes, it is now that its contact here is going to open to de-energize the S2. Okay, so it means that when the timer finishes counting, this S1 is going to open. Okay, and then to follow by when this one opens, okay, this side will close. So when this side closes, it will de-energize the S2 contactor through this relay. Okay, Yeah, so that there will be some time for the motor to operate. Okay, so this is a closed transition type. Okay, we have open transition and then closed transition. The open transition is used on motors, okay, motors from 5 horsepower below. Open transition, it is used on motors from 5 horsepower and below. And then closed transition is used on motors above 5 horsepower. Okay, now let me tell you something here. Now, why is it that, okay, why is it that the S2, okay, the S1 would have to open first before this? Okay, now, assuming the motor is big, okay, this is a closed transition. Assuming the motor is a bigger size motor, all right, and then they all open at the same time. The moment they open, it means that power is going to cut from the motor. Okay, power is going to cut from the motor. So when the power cut from the motor, it means that the motor will still be in operation. All right, so it will still be in operation. So in that case, the motor is going to act as a generator to generate some voltage, back voltage here. So when the run contactor energizes, okay, and also apply the 3-phase voltage onto the motor, it means that the two voltages are going to meet. And in that case, it is going to cause a high surge current, high transient current, okay, and also it will trip breakers, it will blow fuses, okay, yeah, and also cause voltage dips or voltage drops on supply systems, all right, on supply systems. So it is always important that when you are installing an auto transformer, okay, for a motor, you should make sure you look at the size of the motor. If the motor is above 5 horsepower and above larger size motors, you should make sure you use closed transition auto transformer, all right? Okay, they are all the same, but the open and closed, they will depend on the control circuit, all right? You should make sure that the control diagram is an open transition or closed transition based on the motor size, all right? Yeah, so engineers, this is simple auto transformer starter, all right, that we explained. It is so simple, okay? So make sure you look at the diagram well, you watch the video to the end, okay? And also, please make sure you subscribe to this channel. If you are new, there are more practical videos, okay? So make sure you subscribe to this channel, all right? And then you hit on the bell icon, you select all, okay, in order not to miss my videos. And also like the video, put down your comment, and then share the video to your friends, okay? So I'll see you in my next tutorials. Thank you.